Good afternoon, dear students. Good morning. On previous lesson, we were integrating so we were calculating integrals from uh, rational fractions and irrational and some irrational functions. And today we're having the third practical lesson. It is about integration of trigonometric expressions, and also we will use trigonometric substitutions for uh, irrational functions. Okay, so let's start calculating integrals. So the first integral is the following: cosine of x multiplied by sine over 3x. So how to solve it? We don't have a formula for integral of product like for derivatives, so we can differentiate product easily. But for integral, we have to transform it somehow. So we need to transform uh, the product into the sum. So let's look into formulas. I don't always remember the formula of transformation sum product into the sum, to be honest. So let's look into it. And so we will use some help. I just remember that 1 second will be here. So yes, so now this. So cosine multiplied by sine. So cosine of x, cosine of x and by sine uh, y. So it equals, so sine of the sum minus sum of the difference. So in this case, what do we have? So x, so sine over 4x. And let's be careful with signs. So in this case, y is 3x. So minus sine of minus 2x. So plus sine of 2x dx. And now we know how to integrate such expression. It's quite easy. So the result will be the following. Minus 1 over 4 cosine of 4x and minus 1 over 2 cosine of 2x plus c. Any questions about this exercise? Okay, I guess no questions. So let's move next. We will skip exercise B because it's similar to A, but here is a product over 3 trigonometric functions, but it is solved analogically, but more actions need to be performed. So let's move to exercise C, another case. So square of the sine. So again, we don't have such integral in the table. So we need to transform this expression with using the following formula. So we have such formulas for degree reducing. So the following: 1 second. So 1 minus cosine of 2x. And yeah, for cosine square, I believe we will need it as well. So I will write it 1 plus cosine over 2x. So I will rewrite this integral into the following form. So I will use this expression. So it is transformed to the sum. So not sum, difference. Okay. And we can integrate this expression. So 1 minus 1 over 2 sine over 2x plus constant. So any questions about this exercise? Is everything clear?
Yes.
So we use such approach for even degrees in so for even degrees for sine and cosine. So the next exercise we have. By the way, which command we can Control Shift I? No, no hotkeys. Control Shift L maybe. No. Okay. Let's see. Just use palette. So cosine cube of x. So any ideas how to solve it? Daniel?
I think we can write cosine square x multiplied by cosine x, and then we can use formula of to lower the power of cosine square.
No, we don't have uh, to reduce power of the cosine square in such case. But yeah, so the beginning is correct. So what we will do? So yeah, I will write it like a product cosine square by cosine of x and then so what is actually cosine of x dx? It is the differential of sine. Yeah, by the way, let's rewrite cosine square of x. So from the main trigonometric equality, so it is the same. So cosine square x equals 1 minus sine square x. And cosine x dx is a differential of sine x. So now we integrate such expression by sine of x. So what we will receive? Sine of x minus 1 over 3 sine cube from x plus c. So that's how we solved. Is everything clear? Any questions about it?
I have two questions. First, a bit lower, we have another formula for cosine square x, and why we can't use it?
Oh, well, yeah, of course we can use it, but then we will receive product. We will have to turn product into the sum. So this approach will be faster. So using differential entry technique. Yeah, but of course we can reduce degrees. But let's think how to solve in a simpler way.
I understand, thank you. And next question, so we rewrite cosine x dx like derivative of sine x.
Uh, I will correct you differential. So differential is derivative multiplied by dx. Yeah, so this so we have such equality. So differential of sine x equals cosine x by dx. Yeah, so correct. And now we differentiate it by another. So we use it. So sine of x is like a new variable.
I understand, thank you.
Okay, more questions? If no questions, let's move next. So let's go to integral e. Uh, so we will have to perform a lot of actions here. But we will manage to calculate it. So, for now, let's, first of all, let's reduce the power as much as we can. So, for sine square of x, 1 minus cos 1 minus cosine 2x, and then continuing. So, here, what do we have? So let's also write cosine in power of 4. So how it will be rewritten? So 1 plus cosine square of x. No, stop. Cosine of 2x in power of 2. So that's so it equals uh, cosine of x in power of 4. And now let's expand also this brackets. Yeah, I forgot about, yeah, so I also need to multiply by 1 over 4. So now let we not lose it, I will write everything in details. So for now, like this. Then, so let's multiply these fractions. We already know where 1 over 8 is taken. So now we just, so now we expand these brackets. So 1, stop, or something is incorrect, or just a moment. So, yeah, so I moved out 1 over 2 out of this bracket, so everything is correct. Okay. Yeah, let's expand these brackets. So 1 plus 2 cosine of 2x plus cosine square over 2x. And removing power of 2 here. So now we will reduce cosine of 2x, cosine square of 2x. So plus 1 over 2 plus 1 over 2 cosine over 4x. Okay, and then let's also remove 1 second out of brackets. So it will be easier for us. So 2, 4, 1, and 1. Okay, now let's expand brackets. Let's multiply everything, and then we will do other transforms. So, first of all, we multiply by 1 minus, multiplied by 1. Yeah, by the way, let's write it in a more compact way here. And then continuing. So no, we will not skip any steps. Yeah, moving to the next line because a lot of actions. So the first addend is will look like this because we multiplied by 1, and then so minus 3 cosine over 2x, then plus 4 cosine square of x, of 2x, and plus cosine over 2x multiplied by cosine of 4x. So, so erasing these brackets, and now we will expand, and then we will see what is going on. So, minus 3 cosine of 2x. So here we will remove, so we will receive 1, so 1 cosine over 2x. So removing it. Then minus 4 cosine square of 2x and minus this product. Okay, how to write cosine of 2x by cosine of 4x? So the next expression. So sum of cosine plus, cosine of sum plus cosine of difference. And again, we will expand this expression. So 1, so 2, so minus 2 minus 2 cosine over 4x here. And here, okay, minus 1 over 2 cosine of 6x minus 1 over 2 cosine of 2x. So finally we have the sum. Let's write it in a more compact way. And then we will integrate. So 1, then so minus 1 plus 1 over 2. And now we can integrate it. Finally. Let me see, maybe I'm making a mistake. So E. It is in more easy way solved. Okay, but nevertheless, so let's finally calculate it. So you can look into materials, yeah. So another way of solution. So x plus 1 over 4 cosine of 2x minus 1, oh stop, no, not sine, cosine, but sine, plus 1 over minus 1 over 4 sine of 4x, and minus 1 over 12 sine of 6x plus c. So finally it's done. Any questions about this exercise? yeah, so we had to perform a lot of actions. So how to deal with such integrals where we have so such high powers? So we have to so when we have even powers, we have to reduce the power and then calculate the integral. So transforming everything into the sum and then continue. So let's move to the next exercise. We will have another case. So part F. So we have the following integral. So cosine of x in power of 5 divided by cube of sine of x dx. So we will also transform this integral into the following form. So let's do the next. What do we have? Let's write the numerator in the following way. So cosine of x in power of 4. And yeah, divided by sine of x in power of 3 dx. And then we will use the differential entry technique, yeah, after some transforms. So cosine of x in power of 4 is basically 1 minus sine of x in minus sine square of x. And this expression also in power of 2. Then, so it will be divided by sine square of x. And cosine of x dx is a differential of the sine. So now expand in brackets. So 1 minus 2 sine square of x and uh, plus sine in power of 4 of x. Now dividing everything by sine cube, and we will see what we have. So let's move to the next line. And we will have the following expression. So 1 over sine cube of x minus 2 over sine of x and plus sine x, d sine x. So now we can integrate everything. So sine of x is under differential. So let's finish it. So minus 1 over 2 sine square of x. Divide by, yeah, so we need to divide by minus 2. So everything is correct now. Minus 2 logarithm of module of sine x and plus 1 over 2 sine square x plus c. So any questions about this exercise? So that's how we solve integrals when we have odd powers of sine and cosine. So we try to use the differential entry technique as much as possible. So the solution looks quite easy. So if no questions, let's move to the next exercise, exercise G. So we have the following integral. So dx, then sine cube of x multiplied by cosine of x. Okay, so how to solve this integral? So again, doing the same stuff as we did before. So I will multiply and divide by cosine, or maybe here is an easier solution. Let me check. It is not finished. Okay. So yeah, using differential entry technique, so we will finish uh, in our own. So cosine of x dx, and then sine of cube x, and multiplied by cosine square of x. So again, using differential entry technique, so we have differential of sine x. So here in the denominator we have sine cube x, and multiplied by 1 minus sine square x. So yeah, everything that we need we have. Now let's make a substitution. So we have basically the rational fraction. So we will use such substitution. So t equals sine of x. So dt, and here t square, 1 minus t, and no, 1 plus t. So now let's uh, use the method of undetermined coefficients that we used on our previous lesson. So let's start. So a over t plus b mm, plus b over t square plus c over t cube plus d over 1 minus t plus e over 1 plus t. So doing the same stuff that did before. So now finding the common denominator. So now we are adding all these fractions. At cube by 1 minus t square. So writing it in a more compact way, plus bt multiplied by 1 minus t square plus c multiplied by 1 minus t square, then plus dt cube multiplied by 1 plus t, and plus et cube multiplied by 1 minus t. So now let's expand brackets. at cube minus at in power of 4 plus b, oh, so top 80 square minus at in power of 4 bt minus bt cube plus c minus ct square plus dt cube plus dt power of 4 plus et cube minus et in power of 4. Now we're grouping our coefficients. So for t in power of 4, so minus a plus d minus e. So we will receive system from with the 5 variables, but it will be quite easy to solve. B plus d plus e by t cube. Then what about t square? So a minus c, and that's it for the square. And what about power over 1? Okay, just was bt. And power over 0, only c. So we will receive the following system of equations. 5 equations. So all coefficients, so for all powers of t, coefficients are 0 except power of 0. So b equals 0, nice, and c equals 1. So we already know value of some variables. So now let's continue finding all the variables. So from a minus c equals 0, we know that a equals 1. So here b equals 0. We can remove it. So here is minus 1. And we also can add to these equations, so the first and the second, we will receive 1 plus 2d equals 0. So d equals 1 over 2, and e equals minus 1 over 2. So it's done, this system of equations. So let's write our integral. So the following integral, I equals so 1 over t plus 1 over t cube. What's going on? So what about d plus 1 over 2 1 minus t, and minus 1 over 2 1 plus t dt. So let's calculate these integrals. So we have logarithm of module of t minus 1 over 2 t square minus 1 over 2 logarithm of module of 1 minus t. and minus 1 over 2. Stop. Click. 1 over 2 logarithm over 1 plus t and plus c. Let's mark it in such way. So, for example, c with the wave, just to show that these coefficients are different. So, different values that they mean. And also don't forget to return to old variables. So it will be enough to write like this, where t equals sine of x. Any questions about this exercise?
Could you remember why, for example, c equals to 1, b to 0, and so on?
Yeah, so okay. Let's see. Let's look on at this at coefficients in the initial fraction and in this fraction. So for t in power of 4, we have 0 in this fraction. For t cube, 0 as well. For t square, 0. For t in power of 1 is 0. And for t in power of 0, coefficient, so we have coefficient 1. So that's how we find these coefficients. So we just solve this, so we find them from equation system. Have I answered your question?
Yes, thank you.
More questions?
Could you scroll down a bit?
Yes. So here we have table integrals.
Yes, thank you. I understand.
Yeah, so here be careful for with the signs also. Okay, so more questions or everything is clear for now for everyone? Okay, so moving next to the next exercise. Okay, let me clear everything. So we have uh, the following integral. So tangents of x in power over 4. So let's do the following substitution. So I will show you how to solve it. So tangents of x equals t. Then x equals arctangents of t. Variable function. So arctangents of t. Then dx equals dt by 1 plus t square. So now we will rationalize this integral with this substitution. So what do we have? T in power of 4 and now multiplying by dt. So by dx, dt and divide by 1 plus t square. So now what do we have to do now? This is a incorrect fraction, so we need to extract the whole part, the integer part, but I will not do it now. Let's look into this recording. So we have such uh, answer. So the fraction, the integral will look like this. So t square minus 1 plus 1 by 1 plus t square dt. So now we can easily integrate it. So it's a table integral. So all these integrals are table integrals. So 1 over 3t cube minus t plus arctangents t plus c. And okay, let's move to old variables. It's quite easy in this exercise. So 1 over 3 tangents cube of t. Oh, stop. Tangents x. Tangents cube x minus tangents x and plus x plus c. And that's it. So this integral only looks complicated, but it's quite easy. Any questions about this exercise?
When we expand t in fourth power over 1 plus t square, we like divide like we divide numbers in
Yeah, something like this. So let me show you. Yeah, let me remind how to do it. So we perform the following action. So I just didn't want to waste our time. So t in power of 4 we divide by
yeah, and
square plus 1. And I usually write coefficients here plus 0 t cube and so on. So I just didn't want to do it right now because our priority is trigonometric functions integrating. So to understand it better. Okay, now let's solve the following exercise. So with so we will use it with we will use universal trigonometric substitution. So for such cases, when we have a linear combination of sine and cosine in for example in denominator or in numerator, yeah. So for such fractions. So how to use it? So we substitute t with the tangents x over 2. Then sine of x can be turned into this expression, so just with using trigonometric formulas. And cosine of x is transformed to this expression. So now let's rewrite everything that we need here. So t equals tangents of x over 2. Then so x equals 2 arc tangents t. Then dx equals 2 dt over 1 plus t square. And for cosine of x, so you don't have to transform time. So to do such transforms, they were done before, so they're known. Okay, now let's rewrite such a fraction. It will be rational. So now let's write down the numerator. So it will look like this. Then what about denominator? 5 minus 3 multiplied by 1 minus t square and divided by 1 plus t square. So now we will transform it to the common denominator. So copy and paste in numerator. And we have the following fraction. So 5 over 1 plus t square minus 3 multiplied by 1 minus t square, and 1 plus t square. So, of course, we will simplify this fraction for now. So let's reduce this and this. So we will cancel such denominators, because we don't need such huge fractions. And now expand in brackets. So 2 dt, and then so 5 minus 3, so 8, and so 5 plus stop 5 plus 3, stop, just 5 minus 3, so 2, and plus 8 t square, so 5 t square plus 3t square. Now let's divide everything by 2. Oh no, we will not divide it by 2. We'll do the following. I will write down, so I will move out 2 only from the denominator. And I will move 2t under the differential. So nothing changed here, but we differentiate by 2t, because we have so 2t square equals 4t square. So 2t in power, so this everything is in power of 2. So now let's integrate. This is the table integral. So 1 over 2 arctangents of 2t plus c. And that's it. So that's how it was simplified. And also let's return to old variables. So where t equals tangents of x over 2 plus c. So any questions about this exercise?
No.
So now it is quite easy. But universal trigonometric substitution will be not suitable for such integrals where we have a power of 2, because a lot of fractions, a lot of powers. So in this case, we will use another substitution. Let's just okay. Oh, but we have some time. So okay, let's solve it now, and then we will have a break and move to another point. So dx divided by 1 plus sine square x. So in this situation, so which substitution I use here? Yeah, so we use another substitution. Okay, let's just look into this example and have a break. So here I substitute, so another kind of substitution, t equals tangents of x. So sine square of x is transformed to this expression. So t squared over 1 plus t square. So then we again transform it to such a simple integral, and so table integral, and that's what we receive. So arctangents 1 over square root of 2 by arctangents over square root of 2 plus c. Any questions about this exercise? So we use such a substitution t equals tangents x when we have power of 2 in when we have such combinations. Okay, if no questions, let's have a break for 5 minutes and then we will uh, calculate irrational functions with using trigonometric substitutions. Okay, let's continue. So sharing my screen. So now let's talk about trigonometric substitutions. So we have the following cases of irrationalities for which we can use trigonometric substitutions. When we have a square root, so in the expression the square root of a square minus x square, so we use the substitution x equals a sine of t. When we have irrationality of square root of sum of squares, we use substitution a x equals a tangents t. For this irrationality square root of x square minus a square, we use substitution x equals a cosine of t. So now let's practice. Let's solve these exercises. So the following exercise. So the first case, we have the following irrational fraction. So square root of 9 minus x square and divided by x dx. So we have irrationality a square minus x square, a equals 3. So x equals, so we use substitution x equals 3 sine of t. Then dx equals 3 cosine of t. Well, okay, that's enough for now. Yeah, of course, let's write down what does t equal. So t equals arc sine over x over 3. Yeah, because we will have to return to old variables anyway. So square root of 9 minus 9 sine square of t divided by 3 sine of t and multiplying by 3 cosine of t dt, yeah, and also I lost dt here. So now let's simplify this expression. So what do we have here? So 3 cosine of t by 3 cosine of t dt and divided by, yeah, uh, and divided by 3 sine of t. Let's move 3 out of integral sign and divide this expression or not. So what I have here? So cosine. Yeah, let's reduce the power. And we will receive table integrals. Stop. Sine of t. So no squares. So reducing the power. So 1 plus cosine of 2x. Stop. Oh, no, not reducing the power, but 1 minus sine square of x. Divide by sine, so not x, but t. And divided by sine of t. dt. Now expanding everything. So we have the following integral. 1 over sine of t minus sine of t dt. So this is the table integral, so coseconds of t. To be honest, I don't remember the formula, so let me look into the table, because yeah, so it's not so it's not such often case. So let's see. So dx over okay, so integral of 1 over sine of t equals okay, let me write down it. So um, okay, over sine of t equals the following expression. So logarithm of tangents of x over 2 plus c. So we have such integral and t here in our case. So 3 this integral, and integral of sine is minus cosine, so cosine t plus c. And let's write down, let's remember that initial integral was with the function with variable x, so we need to write down what does t equal. Any questions about this exercise?
How we get 3 cosine t by 3 cosine t, the start of the second row?
So here under the square root we will receive 9 cosine square of t, and then we just remove this square root. So this expression equals 3 cosine of t. Have I answered your question?
I see the next 3 cosine of t near the fraction.
Yeah. So that just be attentive. So when solving your home task. Okay, more questions?
That's it.
Okay, if no questions, let's move to the next exercise, the next integral. So we have the following irrationality: 2 plus a square root of 2 plus x square. So, okay, but dx not under the square root, of course, but out of it. And here we have the following irrationality. So a equals square root of 2. So we use the following substitution. X equals square root of 2 by tangents of t. Then t equals arctangents of x divided by square root of 2. And dx equals so dt by square root of 2 and cosine square of t. So everything is taken into consideration, nothing is lost, so rewrite in our integral. So what we receive? Square root of yeah, so let me remind you this trigonometric formula, so that tangents square of x plus 1 equals the following uh, expression, so 1 over cosine square of x. So it is the main trigonometric equality. So what we will receive? So we have the following. So square root of 2 over cosine of t. and multiplied by by 2. Stop. No, stop. Something is yeah. So the square root of 2 in the numerator must be. So my bad. So and yeah, so this is the expression which was under the root. It was converted to this expression, and here is dx. So we received a new integral. Let me move this numbers out of brackets. So I will move 2 there, and this integral will be taken by parts. So what we will have? Okay, let me start from the new line. So I will take this integral by parts. Yeah, don't forget about 2, but we will return it. We will return to it later. So u will be equal 1 over cosine of t. Du equals okay, let me calculate. So minus 1 cosine square of t by minus sine. So tangents over t by cosine of t dt. If I'm not mistaken, if I'm not losing anything. So, okay, let's differentiate one. So, differentiating this expression, so 1 over cosine of t, so it equals minus 1 over cosine square over t, and multiplied by minus sine t dt. So yeah, sine divided by cosine is a tangents, so everything is correct. So moving next, dv is this differential, so v equals tangents of t. And now let's integrate. So tangents over t divided by cosine of t, and minus the following fraction, minus the following integral. So tangents of t by cosine of t, and tangent square of t divided by what's going on. So tangent square of t, because we multiply this, and divided by cosine of t. Okay. And now let's rewrite tangents square of t. So how we can receive it? So from this expression, so tangents square will be equal this. So 1 over cosine square of x minus 1. So let's write it. So 1 minus, stop. 1 minus stop, 1 over cosine of square minus 1, yeah. Minus 1, and divide and multiply it by 1 over cosine t. Okay, let's write dt here. Then we will expand the brackets and receive interesting integrals. So here we have cosine square of so cosine cube and minus minus 1 over cosine t, yeah, and dt. Let me also expand these brackets on the integral, and you will see something interesting, or you already see it. So minus, and stop. So the first integral and the second and plus this integral. So okay, and so what did you notice interesting? So what we received? So if we look at this integral and if we look at this result, this expression that we have, so again we received this integral. So this integral and this. So if we rewrite it, minus this integral. So we can solve the following. So this integral will be found from the following equation. Okay, let's calculate it even like this. So 2i1 equals, so tangents t of cosine of by cosine of x, and this integral is the table integral. So it is integral of seconds x or 1 over cosine. So the following expression. Let me look into it. So tangents of x over 2 plus p over 4 plus c. And actually it equals this initial integral. So let's write I here. And that's not, of course, the final answer, because we must return to previous variables. So where t equals arctangents of x divided by square root of 2. Any questions about this exercise? What's going on? So, such interesting inertia of the mouse. No questions or questions?
Where we have tangents x over 2 plus p over 4 a bit lower in the answer. Probably not x but t.
Oh, yeah. Thanks for your attention. That was a mistake. Yes. I just looked into the table of integrals. So there is x. So, yeah. So this is the integral. This is the antiderivative of this integral of this function. So any questions?
Could you scroll up, please?
Yeah, or higher.
No, thanks.
So is everything clear, or you have any questions?
Everything clear.
Okay. So let's solve one more exercise, and then everyone will be free for today, actually, for advanced calculus. So the last case. So we have the following case. So x minus a square, x square minus a square. So we use the following substitution. So x equals 1 over cosine of t. Then dx equals, so it equals tangents over t over cosine of t dt, and t equals arc cosine over 1 over x. So everything is taken into consideration. So now let's write down the rationalized integral. So numerator, so dx is written to this. Then x square, so is x1, so 1 over x, 1 over cosine cube over x cube equals 1 over x cube. Damn it. So x square, x cube equals 1 over cosine cube of t. So everything is correct. And what about this case? So 1 over 1, so 1 minus cosine square over x actually equals, stop, 1 over cosine of cosine square x minus 1 equals tangents square over x. So here we have tangents of t. Okay, and now we can reduce this expression. So first of all, let's reduce tangents t. So tangents t is everywhere in the numerators, so it will go away. Then we can reduce cosine of t, and we will receive cosine square of t dt. How to calculate this integral we already know. So we will reduce the power of this expression, so it will be equal 1 plus cosine of 2t dt. So quite a simple case for us. So we have the following integral. So t plus 1 over 2 sine of 2 t plus c, where t equals our cosine of 1 over x. So any questions about this exercise? Or no questions? About previous exercises, so about the whole lesson, about previous lessons?
For now, no.
Okay, so it seems that everything is clear. So now let's finish our lesson. Thank you for your attention. Have a nice day and stay safe. Goodbye.
Thank you. Goodbye.
Goodbye. Thank you.
Thanks
Goodbye.
for the lesson. Have a nice day too. Goodbye.
Bye. Thanks.